All right, so today we're going to be discussing the results of the lab you did the other day. So I've put up a little chart here, substance A, B, C, and D, and we did 3 tests for each of those substances. We put hydrochloric acid on all 4 substances. We did a bromothymol blue test to check to see what the resulting gas, if there was any, and then we also did the flame test for all 4 substances. So we're going to try and decide if there were any similarities or similar particles in these 4 substances. So let's write out the results of the lab. So for substance A, what was the result there when we added the hydrochloric acid? There was sustained bubbling, right? So it bubbled. So bubbles. When we added the acid to substance B, what did we get? Yeah, more bubbles, sustained bubbles, right? What about with C? Was there any reaction? It did get hot. Was there any significant bubbles?
No.
Not really, but it did get hot, so there was heat. So heat formed without a heat source, and it was significant. All right? And what about with D? Cloudy. Any significant bubbles? No? Little air bubbles? Okay, good. I'm glad someone mentioned that. I want to talk to you briefly because I see this a lot. When you're dealing with a powder, or any substance really, but mostly when you're dealing with powders, when you put it into a sample and then you pour a liquid on top, like a hydrochloric acid or water or whatever, sometimes within the powder there can be a few little pockets of air. And then when you pour in the liquid, that pressure or the mixing causes little air pockets to open up and escape. So you do see 1 or 2 or even maybe half a dozen bubbles come up. But if there isn't that sustained bubbling that you saw with samples A and B, you probably shouldn't take that as being an indicator of a chemical change. It's more than likely just a little bit of air bubbles escaping. Now, if you want to avoid that, before you add a liquid, just give your sample a little shake, like a gentle shake, and that should help some of that escape, okay? But every year I get students who will say that. They'll see a couple little bubbles. Oh, there's a bubble. Must be a chemical change. And it's not. It's just air escaping, okay? So don't feel bad. Everyone makes that mistake. So with D, there really wasn't any. So no reaction. All right, when we did the bromothymol blue test, that's testing for carbon dioxide gas. What did we get for substance A?
It turned yellow.
Turned kind of yellow. And you saw what happened when I blew into this bromothymol blue, right? I kept exhaling. It went from blue to green to yellow. So even if your sample only turned green, if you had taken a couple more samples, or if you had a more highly concentrated sample, you probably could have got it to turn yellow eventually. Okay? But because of the way we were doing the sample collecting, some of you let a lot of the air escape, so you ran out, basically. Okay, substance B, what did we get? Green, yellow, so there was a reaction, right? So it changed again. Substance C, anything? You thought it was a little green? You thought it got bluer. A lot of people are saying they thought it got a little bit bluer. There should not have been a reaction with substance C. What some of you might have had happen is a little bit of contamination, because bromothymol blue will also change if it comes into contact with an acid. We just poured an acid in there. So if you got a little bit of the acid onto the pipette and then you put it into the bromothymol blue solution, it wasn't necessarily reacting with the gas. It could have been reacting to the little droplet of acid that you put in there. That's one possibility. Or something might have been contaminated along the way. But there should have been no reaction. And substance D, was there any reaction? No, it should have stayed the same as well. All right, so with the flame test, what did we see as our reaction with the flame test? Kind of a brick red. It was orangey red or brick red, and it was pretty much the same for all three, wasn't it? For all four, wasn't it? Yeah, so brick red, and it was the same all the way along. Okay? So looking at these results, doing these three little simple tests that we did, and looking at these results, what could we say about substance A and substance B? The same? Similar? I would be reluctant to say that they are for sure 100% the same. These are three tests. I would say similar, a strong possibility that they're the same, but I wouldn't go so far as to say they are 100% the same. I could likely give you several different substances that could do this, that would react exactly the same way to hydrochloric acid and to a flame test, and come out with similar results. Okay, but they would for sure or almost definitely have similar properties. Okay, now in this case, A and B were the same. They were both a substance called calcium carbonate. So calcium carbonate. And that was A and B. So even though they looked, that was the main ingredient in those two substances. So even though they looked very, very different, substance A was just shells from an egg from the store, and substance B was marble chips or marble rocks. So two things that look very, very differently, but their chemical composition, the main ingredient was calcium carbonate. So they were pretty much the same. Substance C, and I want to make sure I get this right, was calcium hydroxide. So calcium hydroxide, and this is going to take us into our discussion on polyatomic ions, because we're going to look at what the heck these brackets mean and this number. That's for our next lesson. But it also had calcium in it. So you can see there is something similar about the two, right? Between substance A and B and substance C, there was something similar. They both had calcium. All right? What was the same as far as the reactions go, as far as the tests go, for these first three substances? They didn't react to the hydrochloric acid the same. They didn't do the same reaction for the bromomethyl blue, but flame test was the same. So if the flame test was the same and they both had calcium, what do you think we could say about substance D? It more than likely had calcium in it as well. And it did. So it did have calcium in it. The other part was sulfate. Calcium hydroxide. So again, you can see in all four substances we have something similar. And the flame test here was actually testing for that. If you have a substance that's got calcium in it and you do a flame test on it, it will burn a brick red color. And that's how you know test for this presence of calcium. All right? So that was our little investigation with the lab. That was taking the results that we had and applying it. So if, say, on a test or a quiz, I gave you something similar, and I said, okay, substance A, B, and C all do this, and substance D does this. Going through these results, you should be able to notice or find the patterns or find things that are similar and also find things that are different. Okay? So we know that these two, A and B, are going to react with hydrochloric acid. The other one, C, reacts, but in a very different way. So that's just the chemical reactions. Now, in grade 10, 11, and 12, that's when you'll start actually taking apart these chemical reactions and looking, well, what are the products that were produced? How did this happen? Right now, we're just kind of looking at the composition of the different particles. Okay? So, That was the other day. I hit yes.